Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a probability and statistics one, and the paper code of this paper is 9709/51 for the session May June 25. Let's start our session with the question number 1. Question number 1 says the masses of the bags of rice made by a company are normally distributed with mean mu kg and standard deviation 0.14 kg. The probability that the mass of a randomly chosen bag of this rice is less than 1.48 kg is 0.22. Find the value of mu. It's one of the very easiest questions because they have already told us to apply the normal distribution concept. So let us start with our solution. X belongs to normal distribution, and you know the parameters for normal distributions are mean as well as variance. So mean is mu and variance is given square of standard deviation, that is 0.14 square. Well, then the probability of X is less than 1.48 kg. Less than 1.48 kg is 0.22. Probability is 0.22. Now we will have to standardize the score. If we standardize the score, z less than 1.48 minus mu over standard deviation. Standard deviation is standard deviation is 0.14, and our probability is 0.22. Well, now from this step I am going to show you the graph, actually what it is actually. So let me show you the graph. They have told that our probability is 0.22. Okay. Now, and this probability is lying to the left part of z score. So left part, suppose this is our z score. Okay. As it is lying on the left side, look at this, less than z score. So less than z score, it is actually left side. Okay. Left side. If this is our z score 1.48 minus mu over 0.14, our probability is 0.22. So only this shaded part is our probability to be obtained. Okay, for this one, how can we find? Look at the second diagram of figure. You can see that this red portion of the first figure is exactly as same as the red part or red shaded part of the second diagram, because we know that normal distribution graph is always symmetrical. Now for this portion is required to be obtained. For this portion, what we will do, from whole of the probability we will subtract the left part, the larger part. The left part is the dark shaded part. This part is to be subtracted. This part is to be subtracted from whole of the probability. Then we will get our probability is 0.22, and we are going to find the corresponding z score when the probability is 0.22. Well, so for this, what will we do? We will just do the whole of the probability is this, from this. And one thing is sure, that if this tiny part on the right side is 0.22, what about this dark part? Dark part must be 0.78. So let us write here 0.78. This part, dark part, is 0.78 because total probability is 1. Okay. Now one more thing is this, as our actual z score is lying on the left side, so definitely it is negative z score. So we will have to write this probability of our z score must be negative, as I have already explained, negative. Now for this probability 0.22, instead of 0.22 we will find the corresponding z-score when the probability is 0.78, because we require the greater probability. Remember, whenever you find the corresponding z-score, always you prefer for greater probability, because none of the probability given in the probability distribution table is less than 0.5. Let me show you. Look at this. The beginning of the probability is 0.5000. That means there is no other probability given in the probability distribution table which is less than 0.5. That's why always we opt for the greater probability between the two, and z-score doesn't get changed. Just z-score, if z-score is swiped from left to right or right to left, it is just a matter of symbol. If it lies on the left side, it is negative. If the z-score lies on the right side, it is positive. Okay, our probability is 0.78. Okay, so for 0.78 there is no exact probability given in the probability distribution table, but we can find here. Look at this. If you can see that here it is 0.7794. This one is 0.7794. If we add up 6 to this, it is going to be 8. Okay, we are not searching for z score, we are probability, sorry, we are not searching for probability, we are finding the z score. So corresponding z score is, the row is this one. It is, first row is this zero point 0.7, then column is also 7, so 0.77, and the third column is 2. So our corresponding z score for the probability of 7 8 is 0.772. so we are going to write this corresponding z score, and as I have told, the z score is lying on the left side, so surely this is negative. That's why we will have to write negative 0.772, 0.772, and the probability is going to be 0.2. That means this tiny part on the left side is 0.2. Well, now if we compare the coefficient, that means 1.48, the z score must be equal minus mu over 0.14 is equal to definitely this z score. Both of them are z score, so they are supposed to be equal, minus 0.772. Well, then we require our mu. If we isolate mu, it is going to be 0.772 into 0.14, and if we transpose 1.48 to the other side, it is going to be 1.48 to be added. Now using our calculator, we will find that our mean value is, hence our mu is going to be 1.588. Is there any restriction to use the decimal point? Okay, we can take three significant figures. It is going to 1.59. That's the value of mu of this question. So let's move on to the next question, immediate next question. Before that, let me show you the whole of the solution at a glance. The next question says, find the number of different arrangements of the 8 letters in the word kangaroo in which two A's are together and the two O's are not together. So let us draw the scenario first. There are total 8 letters. So 1, 2, 3, 4, 5, 6, 7, and 8. Out of 8, these twos are together, 2A. Okay, these two A's are together. Okay, then as they are together, they are supposed to be one body. Okay, then how many are left? Look at this. O's cannot be together. O's cannot be together. So these two space will go away. So how many are remaining there? There are 4 remaining. Now what about the O's? O will, here also it can be avoiding O because O has restriction. So except O, let us arrange the rest of the letters. So there are how many places are there? I mean, how many units are there? 1, 2, 3, 4, 5. Then there will be 5 units. Let us write number of arrangements. Number of arrangements. Number of arrangements equal to. So as there are 5 places, I mean 5 units now. One, one, two. Let me write in 1, 2. So this is first place, then second place, third place, fourth place, and 5 place. In 5 different ways they can be arranged. So let us write 5 factorial. Now about O. For O, what are the places left for O? Let me show you. O can be this O, as they cannot be together, so O can be over here or in this blank space or there or here or there. Even O can be over here. So finally, how many places are there for O? 1, 2, 3, 4, 5, 6. So O can be placed in 6 different ways. Okay, into 6, into 6, into 6 permutation. 2 out of 6 places there are 2 O's, so they can occupy only 2 places. And again, we have not forgotten that O's are actually identical letters. So for identical letters, we will have to divide by 2 factorials. Now let us calculate this. It is going to be 5 factorial into, that is 6 factorial, over, if we subtract 2 from 6, it is 4 factorial. Again, there is 2 factorial. So 2 factorial is going to be 2 into 2 factorials. So numerator is 5 factorial into 6 factorial divided by 4 factorial into 2 factorials. So our final answer is 1800. So in 1800 different ways they can be arranged. Well, then the next question says, a fair 8-sided dice has faces labeled KANGAROO. The dice is rolled repeatedly. Find the probability that fewer than 6 rolls of this dice are required to obtain an A. From the question, we have understood that it's a geometric distribution, because whenever an A is obtained, then our experiment is over. So let us write X belongs to geometric distribution, and in geometric distribution parameter is only probability of success. So there are 6 letters. Out of 6 there is only one A, sorry, 2 A's. So it is going to be 2 over 8. So 2 over 8 means actually 1 over 4. So our probability is 1 over 4, means our P is equal to 1 over 4 successes. Probability of success is 1 over 4, and probability of failing in each experiment or each trial is 3 over 4. Okay, now we are going to find the probability of less than 6 attempts. So less than 6 attempts means it will take 5 attempts, or less than 5. And for this we know a formula is 1 minus q raised to q is what? 3 over 4 raised to how many times? 5 times. Because in all 5 times he didn't fail. Okay, somewhere he succeeded. Finally, it is going to be, our result is 1 minus 3 raised to 4, 3 over 4 raised to 5 is 0.763. 0.763. That is our answer. Then the immediate next question says that find the probability that the second A is obtained on the sixth roll of the dice. In this question, there are two information given. Look at this. Find the probability that second A. It is all about second A. That means second A obtained on the sixth roll. So what about the first five rolls? In the first five rolls, once A was obtained out of five trials, once there was success, but four times it was failed. But at sixth roll, surely sixth roll is sure. On sixth roll it was nothing but success, so we can write probability of what, that is second a on sixth roll, on sixth roll equal to, on sixth attempt it was nothing but success, and our probability of success is 1.4. And what about the previous first rolls? Among these five rolls, in five rolling, only once he got succeeded. So probability of success is 1 over 4 once, but he failed how many times? 4 times. So 3 over 4, he failed 4 times. So somewhat this is a binomial distribution first, but for the first five rolls it is binomial distribution because we don't know when he got succeeded. So it is going to be 1 over 4 into 5. Choose one is actually 5, we know, and 1 over 4, 1 over 4, or it can be written as 3 over 4. How many times? 4 times. So using our calculator, we get the result as 0.0989. If we round it up to three significant figures, 0.0989. That is what our final probability is, and I can show you whole of this page at a glance. Yes, that is what the whole of the page is. Let's move on to the question number 3. Question number 3 says, last Sunday, teams of runners took part in a charity event. The time taken in seconds to run 50 meter was recorded correct to one decimal place for each runner. The times recorded for 11 runners from each of the girls and the herons are shown in the table. Draw a back-to-back stem and leaf diagram to represent this information with girls on the left hand side. Okay, so girls will be on the left hand side. Let us write girls, and on the right side there will be herons, Well, then we are going to write a back-to-back stem and leaf diagram. Among all of the values, the minimum value is 7 and something. So let us start with 7, 8. After that there will be 9, and let's see whether there is any time given more than 10. Yes, there is. So we can write here 10. Well, then first of all we will have to find the times of girls. Okay, girls start from for 7. Actually it is for girls, it's already arranged, so we can write here 9. First one is 9, and for after 8 there is 2, 3, 6, 6, 8. So 2, 3, 6, 6 as well as 8. Then after 9 there is 2, 7, 8, 0. So let us write 2, 7, 8. 2, 7, 8. 2, 7 as well as 8. Then after 10 there is 0 and 4. 0 as well as 4. Then for herons, it's not arranged, but we'll have to arrange. Let's see how many digits are there after 7. There is 1, 5, 3, 7. That is 1, 3, 5, 7. So 1, not 7, it's after 8. So 1, 3, 5, 7. 3, 5 as well as 7. Then after 9 there is 2, 3, 5, 7, 9, 9. 9 two times. So 2, 3, 2, 3, 5, 7, 9 as well as 9. Then after 10 there is only one digit which is 8. Okay. Now we will write our key. What to write in our key? Let us write the hints or key. Remember, this is one of the parts of this solution to be written. Key is 2, then 8 and 1 shows that shows that girls took 82 sorry 8.2 seconds 8.2 seconds and herons took 8.1 seconds 8.1 seconds. So please don't forget to write this notation just after the stem and leaf diagram, because key matters. You should explain in brief what you have written. Well, then the next question says, next question is number B. It says, find the median and interquartile range of the times of the runners from the girls. So for IQR and median, actually for IQR we should have this information. Let us see. First our median. So median should be written median. Then our interquartile range IQR. IQR. Let us see how much is our lower quartile, then median. Look at this. If we look at our stem and leaf diagram, we will see there are total 11 data. So our median will be 11 plus 1 means 12. 12 divided by 2, 6. So sixth data is median. Let us see 1, 2. Remember, you must not make any disorder while counting this. So we'll just closest one is the first one. Okay, here the first one, here this should be the first one, here this one. Remember, the closest one from the digit should be counted, or if you count from the farthest one, again in every case you will have to follow the order. Well, so our sixth value is sixth time is our median. So let us count 1 2 1 2 3 4 5 6. So this is our median time. What is our median time? It is 88, or I mean 8.8. Okay. Then the lower quartile will be, as there are total 12 data, means 12 over 4, that means third one is the lower quartile. This is lower quartile. We can write here lower quartile 1, and the third quartile is going to be 1 2, that means 3. This one is the upper quartile. Okay, third quartile. So our median is 8.8 Median is 8.8. Let us write it is 8.8 seconds. 8.8 seconds. And IQR, that means upper quartile minus lower quartile. Upper quartile is 9.8 minus our lower quartile is 8.3. 8.3 seconds. So it is going to be 1.5 seconds. Okay. So that is what the answer to the question number 3. Let's move on to question number 4. Question number 4 is on the next page. Oh no, this is not question number 4. This is the next part of question number 3. Okay, it says that two other teams of runners, the Eagles and the Swifts, also took part in the event. The recorded times in seconds for 20 runners from the Eagles and 30 runners from the Swifts are denoted by X and Y respectively. It is given that sum of X is equal to 175.0 and the mean of Y is 8.4. Find the mean of the times taken by all 50 runners. So from this question, we know that this is a coding data. So sum of X means total value of Eagles. Total time taken by Eagles is 175.0. 175. And then sum of Y. Sum of Y is going to be, here mean is 8.4 and total number of runners in the second Swift. Swift is 30 runners. There are 30 runners. So it will be multiplied by 3. Hence it is going to be what? 8.4, that is 252. 252 is the total time. Well, now we are going to find the mean. Hence our mean is going to be sum of X plus sum of Y. Sum of X plus sum of Y. This is the way to find from coding data. Over total number of runners is 20 plus 30 means 50. It is going to be 50. Then 175 plus 252. 252, which is to be divided by 50. If we divide it, and finally we will get the answer as 8.54. So if we divide it, it will be 8.54 seconds. Here you can write seconds, and that is what the answer should be. Let us write here the mean value is this. Well, the immediate next question says it is given that sum of x square is equal to 1823. It is also known that the standard deviation of the times taken by all 50 runners is 1.38 seconds. Find the value of sum of y square correct to one decimal place. So remember, in variance and standard deviation, actually coding data doesn't make any change. So it is simply, we know that standard deviation is equal to square root of variance. So square root of variance, I mean standard deviation, sorry, they have given standard deviation. So let us write standard deviation. Standard deviation is equal to, what is the standard deviation given? It is 1.38. 1.38. And standard deviation doesn't make any change in coding, so it's all the same. That is our sum of x square y square, sum of x square plus sum of y square over total number of participants, which is 50, minus mean value square, that is whole of mean value. So mean value was, we can write our mu square or ex whole square, whatever you tell, equal to 1.38. Instead of mu, I think we can write the value. How much was our mean? Our mean value was, yes, Then it is going to be x square plus x square is given. How much is x square? X square is given 1823 plus sum of y squared plus sum of y square over 50 minus our mean value was already we have found it was 8.54. So 8.54, and if we square both sides, square root will go away and it is going to be 1 point. Here there should be square. It is 1.38 square. Okay, then if we isolate y square, sum of y square is equal to, it is going to be 1.38 square plus, if it is transposed, it is going to be 8.54 squared, then minus 1823 minus 1823. Then finally we will get our sum of y square is going to be 1.38. No, we skipped something. We didn't count this 50. So 50 should be here multiplied. If we multiply by 50, it is going to be 50. Then we will subtract this 1823 1823. So finally we will get, that is 1.38 square plus 8.54 square into 50 minus 1823 is, it's actually 1918.8 up to one significant figures, I mean one decimal point. So that is what the solution to the question number, all of the questions from question number 3. Okay, then let's move on to the next question. The question number 4 is on the next page, which says, every Saturday, a particular community holds a puzzle event to raise money for a new leisure center. Competitors attempt to solve a puzzle as quickly as possible. Last Saturday, 600 competitors took part. The times taken to complete the puzzle were normally distributed with mean 32.4 minutes and standard deviation 2.5 minutes. How many competitors would you expect to have times within 1.2 minutes of the mean time? So here there is a twist in this one, and the distribution is clear that it is normally distributed. It is written, it is normally distributed. So normal distribution we can easily start writing here. X belongs to normal distribution, and for normal distribution our parameters are mean and variance. Mean is given, total mean is, yes, this is mean. Mean is 32.4, whereas our variance is 32.4, and variance is given how much? Variance is square of the standard deviation, that means 2.5 square, and the twist is actually here 1.2. So our x is actually, x is going to be the mean value minus 1.2, that is it should be a negative 32, negative 32.4 minus 1.2. So if we add up, it is 24 and is 36. That means it is going to be 33.6. 33.6. And another one is going to be, x1 is going to be, if we add up 324 and 12, so 336, means 33.6. Now for expected value, we will have to find first the probability and total number. If we find the product of probability as well as total number, that is expected value, I mean mean. So let us find the probability of, they have told that from these two. Okay, these two our variable, these two. So we will write negative 33.6 until 33.6. Okay, now if we standardize our score, it is it will be negative 33.6. Sorry, we made a mistake over here. It is not negative 33.6, it is going to be 32.4 minus 1.2. So 32.4 minus 1.2 is going to be, let me erase this, it is going to be negative, not negative, 324 and 12, means if we subtract, it is actually 31.2. 31.2. We should subtract, once we should subtract from the mean value, and then we should add up to the mean value. Okay, so it is going to be 31.2. If we erase this and rectify this, it is 31.2. Okay, so let us write 31.2. 31.2 minus our mean value. Mean value is 32.4 over our standard deviation. Standard deviation is 2.5. So we can write here 2.5. Then less than z, we are standardizing the score. So 33.6 minus our mean value is 32.4. 32.4 over standard deviation, which is 2.5. Okay, then if we calculate using our calculator, we will get, yes, from 32.4, if we subtract 31.2 and if we divide it by 2.5, it is going to be, actually it is negative, so probability of negative 0.48 until positive 0.48. Well, then what does it mean actually? Look at this, it is in normal distribution. If we notice our z-score, look at this, our z-score is from negative 48 until positive 48. That means our probability is this blue shaded part. Look, this is from the first figure from the upper normal distribution graph. If you see, that is in between this is negative 4, the dark shade, I mean black shaded part on the left side as well as black shaded part on the right side. These two parts are not necessary, so in between this our probability should be this one. Okay, so for this shaded part, what we can do one after the other, let's see. In the second diagram you can see on the right side, and look at this, as the z-score is same, so and the normal distribution graph is always symmetrical, and as the z-score is same on each of the sides, so they are actually the this dark shaded region means probability of this dark shaded region beyond negative 4 and negative zero point 0.4 and positive zero point 0.4 are exactly same. So if we find one of the dark shaded part from the second figure, look at this second diagram, the dark shaded part is lying on the right side. So for this one, how can we find these dark shaded part? From whole of, we require the blue shaded part. Remember, don't get confused and deviated from the question. We require blue shaded part. Okay, so for blue shaded part, what we can do, first of all, we will have to write from whole of the probability. Whole probability is 1. From 1, if we want to subtract this, probability of z less than 0.4. Okay, then no, it should not be less than, because we are going to subtract the right side. So z greater than, it is actually z greater than 0.48. Now look at this, we have subtracted this part. Look at this right part has been subtracted. Okay, then we have got this right part. We are supposed to subtract two similar parts, two similar. From the first figure you can see there are two similar dark shaded parts. This part as well as this part should be subtracted. So long we have subtracted only this portion, then another portion will be similar, so we will just multiply by 2. If we multiply it by 2, then from whole of the probability, these two dark parts, dark shaded region, I mean the probability of this dark shaded region will go away. Now there is another twist. What is that twist? Look at this, 1 minus, this is for, look at this portion is for which part? The only the shaded part, I mean right, black shaded, dark shaded part. So for this dark shaded part, we will have to, how can we find this dark shaded part? This dark shaded part can be found from whole of this. If we subtract left part, probability of z less than 0.48. Okay, then as usual it will be multiplied by 2. Now we are going to find 1 minus, another 1 minus our, I think you got my points. Look at this, there are two dark shaded part, that's why we have multiplied by first two. In the second case, look at this, how can we find our this dark shaded part? So for this dark shaded part, again from whole of the probability we are subtracting left part. That's why we have written here 1 minus probability of z less than 0.48. Well, then now we are going to find the probability of corresponding z-score of 0.48. That means corresponding probability when z-score is 0.48. Let me show you 0.48. Okay, so our, when our z-score is 0.48, that is, this is column and this is row as well as column is 8. So 0.48, the corresponding probability is 0.6844. So let us substitute this value, 0.6844, 0.6844, 0.6844, and as usual the multiplication by 2. So what is it going to be? It is going to be 1 minus, from 1 if we subtract 1 0.6844, it is going to be, let us solve it directly. It is going to be 1 minus 1 minus actually, uh, it is going to be 1 minus 1 plus this. So let it be written this way, 1 minus 2 plus 2 into 0.6844 44. Then easily using our calculator we get that it is going to be 0.3688. 3688. Remember, the question told us to find, not to find the probability. The question told us to find, let me show you, it is actually expected value. Okay, we are supposed to find this expected value. So expected value means total number of experiments as well as uh, product of total number of experiment and probability. Then we will write expected value, hence ex is equal to, hence ex is equal to, total number was 600, so we will multiply by 600. 600 into 0.3688. Then finally it is going to be, if we multiply this, it is going to be 221.28. 221.28. And look at this, this is, they have told us to find the expected value of runners. So runners cannot be in decimal, it is, we can write more than 221, so it is triple two runners, okay, or competitors, whatever you tell. This is runners, and this is our answer. Let me write here answer. Okay, that's all about the solution to the first part of this question. Then question number B, which says, the next question says, in these Saturday's event, 60% of the competitors had times less than 36 minutes. 9 competitors who took part in this Saturday's event are selected at random. So as this, there is total number of selection, I mean total number of experiment is fixed, I mean 8. 9 competitors, 9 has been fixed, so it belongs to binomial distribution. Whenever the total number of experiment is given, then that belongs to binomial distribution. It belongs to binomial, and for binomial distribution, you know, the parameters are total number n and p, total number of experiments, and probability, individual probability is 60%, so that is 0.6. Okay, 0.6. Now they have told us to find the probability when at least 2 and less than 8. What does it means? It means actually more than or equal to 2, that is more than 1. Okay, more than 1 but less than 8. At least 2, at least 2 means it may be 2 or more than 2. Okay, 2 or more than 2 but less than 8. So what does this scenario mean? Actually there are total 9 competitors. Among 9 competitors there should be at least 2, that means there may be 1, or there may be, it's 2 onwards. At least 2 means it's 2 onward, so it will be more than 1. Actually we can write here, instead of 2, if you use this notation, it can be written as, so less than 8 means it will be 7 or less than 7. Okay, so how can we explain this probability? The scenario is, there cannot be less than 2 or more than 7. So what are the remaining probability of competitors? It, let me write, so from whole of the probability, which is 1, from 1 we will subtract the probability when only there was no one who took less than 36 seconds, or probability when there is only one person or one runner who took less than 36 seconds, or there may be 2 cannot be included, so there remains, or more than 7. More than 7 means there may be 8 competitors who took less than 36 seconds, so we are going to subtract that. After that there may be minus probability of x when there are 9 competitors who took less than 36 seconds. So all of these should be subtracted because our probability includes from 1 until, I mean 2 until 7. So less than 2 is 0 and 1, and more than 7 is 8 and 9. Then how are we going to write this? It is going to be 1 minus, when there is no one is less than 36, it is going to be, total number is 9, choose 0. So 0 is, probability is 0.6, that is everyone is beyond this 0, no one. And then 0.4, how many? All 9 are more than this 36 seconds. Or only one competitor who took less than 90, took less than 36 seconds, we are going to subtract that. So 9, choose 1. So 1 took 0.6, how many times? 0.6 once, and 0.4, 0.48, 0.4 raised to 0.4, not 8, 0.4 raised to 8. Then there is another probability, minus, out of 9, out of 9, out of 9, all 9 competitors took less than 9 seconds. Let us see that probability. So all 6 is, no, it is actually 8. 9, choose 8. Minus, out of 10, only one competitor is less than, one competitor is taking less than 36 seconds. So rest, not, so out of 9, one is taking less than 36 seconds. So rest 8, rest 8 are taking more than that. Okay, then out of 9, then there we are going to subtract 8 competitors who may take less than 36 seconds. So 0.6, how many times? 8 times. Then only one student, I mean one competitor, took more than 36 seconds. Then when they are out of 9, all 9, if all 9 takes less than 36 seconds, and probability is going to be 0.6, 9 times, that means no one took less than 36 seconds. So 0.4, no one. So that is what our expression is. So it is going to be, now if we simplify, let me write just at the left side of this solution. Over here we can write, okay, so first one is 1, okay, then 1 minus or equal to 1 minus, then here 9, choose 0, it is actually 9. Okay, 9 into 0.6 raised to 0 is 1, and 0.4 raised to 9. Okay, point, sorry, 9 choose 0 is actually 1. It is going to be, out of 9 people, if we choose only no people, then only there is one way to choose no one. So 1 minus, it is going to be 1 minus 0.4 raised to 9, 0.4, 0.4 raised to 9, second one. And then it is minus 9 choose 1 means actually 9. Okay, then from 9 choose 1, if we take this one, yes, so that you can see more clearly. Well, then it is 0.61, 0.6, 0.6, 0.6 into zero point 0.4, how many times? 0.48 times. Okay, then third one is 9 choose 1, we have repeated 2 times, so let it be just 9 choose 0 and 9 choose 1, it should not be repeated. Okay, then the third one is 9 choose 8. Okay, 9 choose 8, so 9 choose 8 means also 9, we know. So 9 into zero point 0.6, how many times? 0.6 8 times, and 0.4 definitely once. Okay, then the final one is 9 choose 9. 9 choose 9 is also 1. Okay, so it is minus 1 into all 9 has been supposed to be taking 0.6 9 times and 0.4 0 times. Okay, then if we calculate our probability, it is going to be, using our calculator, we find that these probabilities 0.926, that is what our final answer is. And let me show you the whole of the solution on this tiny display. As much as possible, I'm going to show you and explain in the shortest possible time. Well, then the next question. Let's move on to the next part of this question, which is on the next page. Well, question number C says, it says 80 competitors who took part in this Saturday's event are selected at random. Use a suitable approximation to find the probability that more than 50 of these competitors had times less than 36 minutes. So for 36 minutes, the probability is zero point 0.6. So we have come to know from the previous question. But here, the clue word is approximation. Remember, whenever the word approximation is mentioned, it indicates that the distribution is given in binomial. This is a binomial distribution which is to be converted to normal distribution. So let us write x belongs to binomial distribution, and for binomial distribution the parameters are n and p. Total number is 80 and probability of individual or every competitor is zero point 0.6. We have used in the previous question. So for approximation, we are converting this binomial distribution into normal distribution. X belongs to normal distribution, and the parameters for normal distributions are mean as well as variance. Mean is n into p. Okay, if you multiply n and p, that is mean. Okay, so let us do the multiplication. It is going to be 48, and our variance is npq. Okay, 80 into zero point 0.6 into q is 0.4. Okay, so 0.4, if we multiply 48 by 0.4, it is going to be 19.2. 19.2. Okay, this is n, p and q. Okay, variance is npq, and this is npq, and this is np, means product of total number of experiment into individual probability. Well, then they have told us to find probability of what? More than 10. Here it is written more than, sorry, 50, not 10. More than 50 of the, here it is actually, let me show you clearly. It is 50, more than 50, and here you can, it is n and p. Okay, so x is more than 50 competitors is equal to, if we standardize, then z is greater than. Now look at this. Usually we subtract from this x minus mean. Okay, so here also we are going to do the same. We are going to apply the same concept, but remember we are converting the binomial distribution into normal distribution. So whenever we convert from binomial to normal, we should do continuity correction, because binomial distribution is applicable for discrete random variable, whereas normal distribution is applicable for continuous random variable. So if we do continuity correction, then it is going to be 50.5. We will have to add up 0.5 because it is greater than, minus our mean is 48 over our standard deviation. Standard deviation is square root of variance. Well, I think you have understood this continuity correction. Then it is going to be z is greater than, if we do our calculation, it is going to be 0.571. 0.571. Now using our graph, normal distribution graph, let me draw the normal distribution graph. So from the graph we require actually this portion. This is our required shaded region. But as compared to the whole graph, look at this. This is a tiny part, and all the corresponding probability given in the probability distribution table is more than 0.5, more than half. So as this is tiny part, what we can do from whole of this, if we subtract this left part, if we subtract this red shaded part from whole of this, we will get our tiny dark part. Okay, so what we are going to do is we are going to subtract from whole of the probability. This red part is subtracted, so it is 1 minus probability of z less than, left part is going to be subtract 0.571. And using our probability distribution table, we are going to write our probability, corresponding probability for this z score. Let us go back to the probability distribution table. Our, how much is our z score? Our z score is given here. Let me erase the previous one. So our z score is 0.57, 0.57 and 1. So row is fifth row or sixth row. That means this is our probability which is to be added to for the final digit, which is 1. So if we add up 7, 1, 0.571. So our probability is 0.7157 plus 3. So it is going to be 0.7160. So let it be written 0.7160. 0.7160. 0.7160. So finally our probability is going to be how much? If we subtract these from 7160 from 1, we will get our final probability is going to be 0.284. 0.284. Okay, that is what the final probability. So approximation, remember in approximation the question is given in binomial distribution, and we are to find the probability of normal distribution, and binomial distribution is applicable for discrete random variable, and normal distribution is applicable for continuous random variable. That's why continuity correction is a major part of such solution. Well, let's move on to the next question. The next question says, Yes, it says in a group of 20 musicians, there are 9 guitarists, 6 pianists, and 5 drummers. 6 musicians are selected from this 20 to perform at a concert. Find the number of different ways in which 6 musicians can be selected if there must be at least 3 guitarists, at most 2 pianists, and exactly 1 drummer. Okay. So one thing is very sure, this is actually combination because it's all about selection. For selection we apply the concept of combination. So let us write the first one. Total how many guitarists are there? 9 guitarists. So 9 G. Then how many pianists are there? Total there are 6 pianists. Okay. Last of all, there are 5 drummers. 5 drummers. Well, so for the first case, let us write the scenarios, possible cases. Out of 9 guitarists, they have told at least 3 guitarists. So let us choose 3 guitarists, and there can be maximum 2 pianists. Maximum 2 pianists, and number of drummer will be always same. It is 1. This is the first case. Then what is the second case? The second case is, let's take as at least 3, we can take now 4. So 4 guitarists, and from pianist we can take 1 because maximum 2, so we can take less than 2, and another drummist is fixed. So what is the third possible case? Third possible case is, out of 9 we can take 5 guitarist, and from 6 pianists we can choose nothing because they told maximum there may be 2, so 0 is applicable. And final, the number of drummer is always same, that is 1. So what is this actually? It is going to be, from 9 we have chosen, let me write just beside this. So it is actually 9. From 9 we have chosen, let me change the ink. So it is 9 choose 3. Then from 6 pianists we have chosen 2, and from 5 drummer we have chosen 1. And here it is going to be, so it is 9 factorial over 3 factorial as well as 6 factorial, and 6 factorial over, you know how to do this, and using your calculator directly you can show the result, you can see the result, but I'm just expanding one more step. 6 factorial over 2 factorial over 2 factorial into 4 factorial, and 5 choose 1. From 5 if we choose only one object or one person, it is, there are only 5 ways. So equal to, it is going to be equal to, let us write equal to over here. Okay, as I don't have space to write on the right side. And second possibility, so second possibility is going to, out of 9 we are taking how many? 4. And from 6 pianists we are taking 1, and from 5 drummer we are selecting 1. So it is going to be 9 factorial over 9 factorial over 4 factorial as well as 5 factorial. You know how to write this, 5 factorial, and 6 choose 1. From 6 pianist, if we choose one by one, there are 6 ways we can choose them, and from 5 drummer, if we choose one by one, there are 5 ways we can choose them. So let us write that equal to. Then the third possible case is, from 9 guitarists we are choosing 5. So it is going to be 9. From 9 we are choosing 5, and from 6 guitarists we are choosing no one. Then from 5 drummer we are choosing only 1. 5 choose 1. So it is going to be 9 factorial over 5 factorial as well as 4 factorial. And from 6 people, if we choose no one, there is only one way to choose them. After that, the final one is, if we choose one by one 5 guitar 5 drummer, then it will be 5 ways. So let us write just beside this. What is it going to be? If we use our calculator, so number of selection in the first case is 6300, 6300, 6300, and in the second case it is 3780, 3780, and finally there are 630 selections. Now if we write our number of total selections, let us write number of total selection, number of total selections is, if we add up all of this, it is going to be 10,710, 10,710, and that is what the final answer to this question. So the next question, on printed on the next page, let's read the next question. I mean part B of this question. 3 bands will be selected from the original group of 20 musicians. Each band will consist of 3 guitarists, 1 pianist, and 1 drummer. No musician can be in more than one band. The first band selected will play at a concert in France. The second band selected will play in Italy, and the third band selected will play in Spain. So find the number of different ways um, which in which these 3 bands can be selected. So there are 3 different bands. So for 3 different bands, let us write. First one is France. For France, okay, this is for the first country. Then the second band was for Italy. 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 Then third one is for Spain. For Spain. Okay, and in every team, every band, actually number of individual musicians will remain same. So first one will have 3. So total there are 9 guitarists. Out of 9 there will be 3. If we choose, it is selection, so we'll have to look at this, it is selection, that's why we will have to apply the concept of combination. So from 9 guitarists we have chosen 3, and from 6 pianists we will choose 1, and from 5 drummer we will choose 1 drummer. This is for first team. And for the second team, it will be, out of 9 guitarists, how many of them have already been chosen? Already we have chosen that 3, so there remains 6. So from 6 we are going to choose another 3. And for pianist, there are remaining 6, choose 1. This is 6, choose 1. 6, choose 1. Okay, from pianist, it is going to be, how many are there in total? 6. Out of 6, one has gone away, so there remains 5. 5, choose 1. And for total number of drummers is 5. From 5, 1 has gone away, so there is only 4. From 4 we are choosing 1. Next, for Spain. For Spain, similarly, let us see how many of the musicians are left to be selected here. Okay, total 336 have gone away, so there remains only 3. 3, choose 3. From 3 guitarists will have to choose 3, and from 4 remaining 4 remaining 4 pianists, there are we'll have to choose one. 4 choose 1, 4 choose 1, and remaining number of drummer is 3. So from 3 we are choosing 1. Yes, now the greatest of all twist in this question, it is whether we will do addition or multiplication. It is, look at this, it is not addition. You may get confused with this concept. It is not addition, it is actually multiplication. And if you ask me the reason is actually we are simultaneously forming the three teams, three bands. So it is not either France or Italy or Spain, not in this way. Simultaneously all of them are being formed together. So whenever it is actually and, not or. France, band for France, and band for Italy, and band for Spain. It is not like the band for France or band for Italy or band for Spain. It is all of them have been formed together. That's why it is and we know for and in probability we do multiplication. So it is going to be 9 factorial into 6 factorial into 5 factorial. Okay, and the denominator is going to be here 3 factorial into 6 factorial, then 1 factorial into 5 factorial. 1 factorial means 1, so let us write 5 factorial, and here also 5 factorial means 1 and 4, so 1 can be avoided. Then for the second case, into, it is numerator is 6 factorial, and 5 choose 1 means actually 5, so is 4 choose 1, it is 4. So for the first one, if you write 3 factorial into 3 factorial, then 3 choose 3 is actually 1, and 4 choose 4 is actually 4, sorry, 4, and 3 choose 1 is actually 3. So if we calculate the first one, it is 6 factorial will divide this, 5 factorial will also divide this. So it is 2520 number of ways, and in the second one this is going to be 400, and the third one is going to be only 12. If we find the product of all of these quantities, it is going to be 120. The product is a very large number, 120, 120, 96, and 000. 000 ways. This is what the answer to this selection. Now question on selection. Answer. Now we didn't write actually number of selections. So you can write here number of selections. Number of selection is equal to selections, then equal to after this, then whenever you write number of selections at the beginning, so you don't need to write this, don't mention this friends, you will simply write the quantities putting multiplication symbol in between them. For explanation I have just written France, Italy, and Spain, so you just delete or omit this. Well, then the next question. Well, let's solve the final of all the questions of this paper. It says a bag contains 10 marbles, of which 4 are red and 6 are blue. 4 marbles are selected from the bag at random without replacement. The random variable x denotes the number of blue marbles selected. So it's all about blue marble. So first of all, we will have to find the probability of one blue marble. The probability of each blue marble is, probability of one blue marble is, total there are 10, and blue number of blue is what, 6, so 6 over 10, and that is 0.6, and probability of a one red marble, it is zero point 0.4. Surely it is 0.4. Well, then we are going to find probability of two red marbles. Okay, probability of x equal to 2 red marbles equal to. So what are the possible cases when we pick up the marbles to get two blue marbles? It may happen that the first one was blue and second one, first two were blue and second two are red, or it may be first one is blue, second one is red, blue, red. It may be the order be blue, then red. Or in the third possible cases, in third possible case, it may be first one is blue, first one is blue, and next two are red, and final one is also blue. Then what is the other cases? Or first two are blue, or first one is red, first one is red, second one is blue, third one is also blue, second one is blue, third one is also blue, but fourth one is red. Or it may be first one red, second one blue, and third one red again, fourth one is blue. What is the last and final case? Final case is it may be first two are red and final two are blue. Okay, well, then we will have to write the probability. So for probability it is zero point 0.6. So 0.6. Now in this way we cannot actually write them because it is without replacement. Remember, don't ignore these, the clue point of this statement. It has been written that without replacement. So for without replacement we cannot use this randomly. Okay, it is going to be, this is for 1 because 4 over 4 over 10. Okay, so the if the first one is, if the first one is blue, the probability is 6 over 10, 6 over 10. Then the second one is again blue, as there is without replacement. Remember, without replacement. So one, every time you picks a marble, then one marble is decreased. So there are 5 out of 5. There are total 9 out of 9. 5 is red. Then for red, total red were 4. Then out of 9 now 8. Then if one marble is taken away, then there remains 7, and number of red marble has also decreased. That's why it is 3. Now if we look at each of the probabilities, look at this, they are actually symmetrical. Okay, every time if you pick up 4 marbles one after the other without replacement, your denominator is going to be 10, 9, 8, 7, and numerator will also remain, though there will be order, but totally it is going to be same. That's why we can write as there are 6 such possible cases, so we will multiply by 6, and then finally we will find that our probability of having or picking up 2 marbles is going to be 7 over 2, or by doing cancellation also I can show you, that is 5 4 20, then like 6 5 30, 3 30s are 90, so 90s go away. Then uh, it is 24, and this is 6 4s are 24. Okay, then by 8 if we dissolve, it is going to be 3. So finally it is going to be 3 over 7 shown. They have told us to show, we have shown. Let's move on to the next question. Next question says, it says draw up the probability distribution table for x. Okay, so from the previous one actually we can draw up the probability distribution table for this when x is. So what are the possible cases? It may be when x is 0, that means as we are picking up 4 times, suppose we are not receiving any blue marbles, or we may receive only one blue marbles, or we may receive two blue marbles, or we may receive three blue marbles. Total how many blue marbles are there? Total, or x is equal to 4, because maximum there may be 4 blue marbles because we are picking up 4 times. X is equal to 4. Okay, when x is equal to 4, our probability is x equal to 0 when probability of x equal to 0. Okay, then let me copy this. All of these are actually same. So if none of them is blue, so all 4 are red. So for all 4 red, what is it going to be? First one is, how many red marbles are there? 4. 4 out of 10. Then if one is taken, there remains 3. Then 9 and 2 out of 8, and 1 out of 7. So finally, what is it going to be? 4 twos are 8. 8 has gone away. And then 3, it is going to be 3. So finally, we are having 1 out of 20, 210. So it is 1 over 210. For the second one, there is only one blue marble. For one blue marble, the probability is out of 10, 6, and rest of them are red. What are the possible cases? It will be 9, 8, and 7. So first there are 4 red marbles, then there will be 3, and then 2 red marbles. Now look at this. As there is only one blue marble, this blue marble can be found in anywhere. Okay, it may be over here. Let me show you. It may be over here, blue marbles. Okay, or it may be in the third case, or it may be obtained in the fourth case. That means there are similar 4 cases. Okay, so in 4 different ways, one blue marble can be picked up. Now if we simplify this, it is going to be equal to, it will be 4 over 35. 4 over 35. I am not showing the details cancellation. It is 4 over 35. Okay, then the next case. For the next case, there are 2 blue marbles. Okay, 2 blue marbles means it is going to be, first one is, suppose first one is blue and second one is also blue. So this is 5 out of 9, and rest 2 maybe what? Red. So for red, 4 over 8, 4 over 8, or then 3 over 7. 3 over 7. Look, when x is equal to 2, already in the previous solution we have written that when there are two blue marbles, our probability was 3 over, it is just given here 3 over 7. So we can just copy this. It is going to be 3 over 7. So it is unnecessary to be written. We have already calculated this. So let us write it directly. It is 3 over 7. 3 over 7. Now, third case, if there are three blue marbles, so let us see, the first one is blue, then the second one is also blue, 5, 4. So it is 9. Every time one marble is decreasing, then 8. Then the fourth one will be, only one will be what? Red. For red, 4 over 7. So this is one of the cases. Okay. Now we will have to know how many such possible cases are there. Look at this. This is the blue one. Okay. So blue marble may be picked at this one, or the second case, or third pickup, third or fourth pickup. So blue marble can be, as there are three blue marbles, the three blue marbles may be picked first three, second three, or third three, and there is only one red marble. So this red marble may be picked in the fourth case, or third case, or second case, or first case. That's why there are four such cases, and we are going to multiply by 4. If we calculate, it is going to be 8 over 21. 8 over 21. I am leaving this in exact format. Then the final case. In the final case, let us write equal to. All four are what? This one is over here. All four are blue. If all four marbles picked are blue, then it is going to be 6 over 10. Second one is also blue. 5, then 4, as well as 3. All of them are blue. And every time one marble is being decreased, so there is only one possible case when all four are blue. And if we simplify this, it is going to be 6 5, so 6 5 30. Okay, so 3 tens are 30. Then sorry, a little mistake has been made. It will be 3 will be over here. Now 3 nines are 20. This 3 can dissolve this, 4 can dissolve this by 2. So finally our, let us do the calculation once again. So 6 5 are 30 by 10. If we divide, it is going to be 3. Okay, then these 3 and these 3 are 9. Then 4 is going to be, it is 2. So finally it is 1 over 14. So these are the all 5 possible cases of probability, okay, of picking up blue marbles. Now we are going to draw the probability distribution table. As I don't have space over here, right side, I think on the left side I can write. So before moving on to that later, let me write that probability distribution table. Okay, using different ink. Probability, probability distribution table. Let me draw the table. This is our probability distribution table. Now we are going to insert the values, I mean probabilities. First one is 1 over 210. I am leaving them in exact form. You can leave it as 3 significant figures, or in decimal fraction. Then second one is 4 over 235. 4 over 235. 235. I will have to zoom it out actually. Second one is 4 over 235. 235. And the third, when x is 3, our probability was 8 over 4 over 35, not 235. It was only 35. So let me erase this. When x was 3, for 3 it was 8 over 21. Next one is 8 over 21. What was the probability when it was 2? 1 over 210. Second one is 4 over 35. Third one is 3 over 7. 3 over 7 we can copy from here. Look at this. When there are two blue marbles, the probability is 3 over 7. So it is 3 over 7. Then if there are three blue marbles, the probability was 8 over 21. 8 over 21. And when the probability was 4, I mean probability of having 4 blue marbles is 1 over 14. 1 over 14. I left them in exact form. You can convert it into decimal fraction also. Well, then the next one. So for the probability of the next one, probability that at least two of the marbles chosen are blue, given that at least one red marble and at least one blue marble are chosen. So what are the possible cases? First of all, we will write for probability when at least two marble. Probability of at least two blue marbles. Two blue marbles and at least one red marble. At least one red marble, one blue marble means already there are two blue marbles. So at least one red marble. One red marble is equal to, or if you are confused, I can write this. You may get confused that why didn't I write the blue one blue, though this is actually, if you look, you may get confused that why didn't I write blue, though it's all the same. That means at least two blue marble. Here already there is one blue marble included. Is equal to, what are the possible cases? The possible cases are there will be two blue marbles, then two red marbles, okay? Or probability of there are three blue marbles and one red marbles. So it's actually, we have calculated the probabilities from the previous page. When probability there are at least, I mean probability of two blue marbles. Let us see from the previous page. Probability of two. Probability of two is this one, and probability of 3 is this. So 3 over 7 plus 8 over 21. 3 over 7. 3 over 7 plus 3 over 7 plus 2 of 8 over 21. 8 over 21. So it is going to be actually 56 plus, it is 8, not 81. 56 plus 56 plus 63. 63. It is 21. Okay. Then 147. So finally it has become 119 over 14. Not 14, 147. Well, then probability of at least one, probability of at least one blue or and one red. Okay. What are these possibilities? These are actually, there may be probability of one blue. If one blue, then there will rest three is going to be red, or there may be two blues, rest two is going to be red, or there may be three blues and one red. So what does this means? Actually, there is the probability of one blue, two blues, as well as three blues. So let us see what are the probabilities of one blue, three blue, and one blue, two blues, and three blue marbles. 1, 2, 3, not this page, over here. So for one, it is probably 1 over 210. Sorry, that is not for one. For 1, it is 4 over 35. For 2, 3 over 7. And for 3, it is 8 over 21. So whenever there are one blue marbles are chosen, so definitely rest of them are red. But here you may ask a question that why are we not writing probability of 4 blue marbles? If all 4 are blue, then what will happen to this condition? This condition is there should be at least one red. So all of them can neither be red nor blue. Okay, so maximum 3 can be either blue or red. So for one blue, we have got 4 over 35. 4 over 35. 4 over 35, when there was only one blue marble picked up, and when two blue marbles were picked up, it was 3 over 7. And for two blue marbles, then three blue marbles were picked when probability was 8 over 21. Okay, 21. Then if we simplify, it is going to be 105 is our LCM. Then 12 plus 12 plus 45 plus 40, 45 plus 40. If we simplify it more, it is going to be 97 over 105. 97 over 105. Okay. Then we are going to find our final probability. Final probability is that at least two of the marbles. So let us write probability of at least two blue marbles. Two blue marbles, given that at least one blue, one red. One blue, one red is equal to, it is a fraction, probability of at least two blue intersection. At least one blue and one marble. One blue and one marble. This is and, remember, not or, so there should be multiplication, okay, between two this, over probability of at least one blue marble as well as one red marble. All of the data have already been collected. So first of all, let us see what is the probability of at least two blue marbles and one blue. It is not blue. So probability of at least two blue marble intersection, at least one blue marble was, at least one red marble is this 119 over. So we can write 119 over 147. 147 divided by the denominator. Denominator is going to be what? At least one blue or red marble, for which the probability is 97 over 105. 97 over 105. Now if we divide each of the first quantity by the second quantity. 19 over 147 over 97 over 105, it's going to 0.876 is our probability. 0.876 is the final answer to this probability. That's all about this paper. I tried my level best to explain every tiny part of each of the question. If it is beneficial for you, please pray for all the students of the world so that Allah blesses each and every student with the beneficial knowledge. And if you think that this channel is worthy of subscribing, then you can, or if you think that it is worthless video, then there is no necessity of subscription. So thank you all for being with me. Fi amanillah. Let me show the final page once again.